Alright, welcome to the living answer key for stoichiometry problems number 2, pure substances and solutions. You should have watched the lecture on moles versus molarity before you try to do this, but after that, now we are going to go through these problems. I probably went through some of these problems in the lecture, so if you are watching it after the lecture, you might want to zoom through until you get to them. If you're not, if you're just jumping right to here, we'll start with number 1. We have learned already in the past for a pure solid, pure liquid, pure gas, moles equal mass over formula weight. Mass is always in grams. Okay, and then formula weight's the number that you get off the periodic table when you add all of the elements together. Now when you find moles of a solution though, we're going to take this thing called molarity, and molarity is just the moles of stuff in the volume that you have, and you're going to multiply that by volume, but you have to make sure that the volume's in liters. So get that written down, pause the program if you need more time, and let's get on to number 2. Read the problem and give it a try. Alright, so the question says, a solution is prepared by dissolving 15 grams of nickel 2 nitrate in enough water to make 250 milliliters of solution. What is the molarity of this solution? So basically what this is saying is I'd like to know the molarity, okay, but we have grams. So we can't just dissolve our grams into our volume. We'll have to change this into moles. So as soon as you see a grams, the first thing your brain should be thinking is, well, if I see grams, I probably need to use moles equal mass over formula weight. So we do have a mass, and that's 15 grams. Pause the program here and try to find the formula weight and see if you can't pick it up from here. Can you answer it from here? Alright, when you add 1 nickel, 2 nitrogens, and 6 oxygens together, you get a formula weight of 183. When you divide 15 by that, you get 0.082 moles of your nickel 2 nitrate. Now, this we can start to use this equation now. We can now say that molarity is equal to moles, okay, over your volume in liters. So we have the moles, so we're going to put moles over, now remember the volume has to be in liters, so let's take a look at this. 250 milliliters is not liters. We have to take our decimal that's right here and go 1, 2, we got a quarter liter here, so we're going to divide that by 0.25 liters. You divide those, the number that pops out in your calculator is 0.033 when you round. Now, you got to find a unit. What is the unit for molarity? Big M, and then it never hurts to write your formula. Let's have you read number 3 and give that one a shot. Alright, hopefully you're replaying the program after you've stopped the program and tried this one out. Which has more molecules? So I know I need to find moles of both of them. So I'm going to look here and I see milliliters and molarity and I see liters and molarity. So I know these are both solutions. So I'm going to find moles of each. So my moles of my first sodium bromide sample, I'm going to take my 0.5. Okay. I'm going to multiply it by, I can't do 128, I'm going to do 0.128. And we're going to get 0.064 moles of NaBr. Now over here, if you haven't paused the program and tried this yet, I want you to try this one by yourself now. To find moles of this though, I'm going to take my 0.12 and I can multiply it by 1.38 because it's already in liters. When you get that, you get 0.17. Which one is bigger? Boom. Okay, we have more sodium bromide in the second sample than in the first sample. Okay. Question number 4. Pause the program, give it a read, and see if you can't answer it. Alright, so whenever you see an equation, the first thing you should be thinking is it balanced? The question says, consider the following balanced chemical reactions, so that is balanced. And we're going to read this here. Okay, it says, consider, student adds 42.6 milliliters of a 2 molar hydrochloric acid solution to a flask. She determines that it takes 40 milliliters of an NaOH solution to neutralize that hydrochloric acid. What was the molarity of the NaOH? This is our question. Now, I personally like to write the information up into there so I can kind of see what I'm looking at. I don't like this number here, so I'm going to go 1, 2, put a 0 in front of that. So I know that I have 0.0426 liters of hydrochloric acid, and I know the molarity is 0.22. It takes me, again, don't like this number, so I'm going to go 1, 2, 3. sorry, that was in highlighter, but 0.04 liters to neutralize it, and I do not know the molarity. Okay, so just like any stoich problem, we have to find moles. So the first question here is, are these solids or are these solutions? And that answer to that is these are solutions. So as soon as you think you can do it, you should always stop the program and keep going, and then I will come in and tell you if you were right. Okay, so which one do I know more of, HCl or NaOH? I clearly know more of HCl. I actually have enough to get moles of HCl. Okay, so I'm going to do moles equal molarity times volume in liters. So I have those two numbers right there. I'm going to write them down here, and then I'm going to get a number, 0.0094 moles of HCl. Now, just like any other stoich problem, I got to check my coefficient ratio. That is a 1-to-1 ratio, so that's also how many moles of NaOH I have. The question, though, says, what is the molarity of the NaOH? Well, you know, if I have moles of NaOH, and I have volume of NaOH, can we solve for the missing variable? Of course. So I'm going to do 0.094 is equal to, looking for M, and then we have the volume. Let's put that down, right down here. How do I solve for this? I solve 0.04 gives M by itself, so I divide this side by 0.04. When you punch that into your calculator, the number that comes out is 0.24 molar NaOH. That's the M. Okay. I would take a look at number 5, see if it's balanced or not. Pause the program now and try to give it an answer. Alright, hopefully you balanced it like this. And then hopefully you at least got to write your information up in there. So what volume of NaOH, we have the molarity of NaOH, is needed to neutralize, and again I'm going to write 0.02 liters of 2 molar sulfuric acid, H2SO4. Now again, if you don't know where to go, if you want to pause it now, put what you have into moles. Alright, you know the most about sulfuric acid, so you're going to write moles of H2SO4. I'm going to multiply these two things together, and I'm going to get 0.04 moles of H2SO4. Now, just like we've done before, this is a what to what ratio. What to what ratio? This is a 1 to 2. It's getting bigger, not smaller, so I'm going to multiply this by 2. Now the question here says what volume of our NaOH. So if I have moles of NaOH, I have the molarity of the NaOH, and I'm looking for the volume of NaOH. All I have to do is divide this by 1.85, get it by itself, divide this by 1.85. Your calculator spits out this number, 0.0043. Now, if you put it in as liters, it also comes out as liters. Okay? You can leave it like that, or if you want, because we measure out milliliters here in class, move it 3 times the other way, you're looking at 43 milliliters of NaOH. Alright, I suggest again, make sure you can balance this, pause the program, see what you got. Alright, did you get the right answer? Let's make sure. So it says, what volume of 0.63 molar KOH must be added to neutralize, again I'm going to change that into liters, 0.0129 and 0.82 molar HCl. Which one do I know the most about? I know the most about HCl, so I'm going to find moles of HCl. I'm going to multiply those two things together. Now I have 0.11 moles of HCl. I have a 1-to-1 coefficient ratio. Now, have my KOH here. I know moles of KOH is equal to, now, I want to find the volume in liters, and I have the molarity, so then I divide this by 0.63, divide this by 0.63, and the answer you're looking at, where to go, okay, is 17.5 milliliters, or your calculator spits out with this one, 0.0175 liters. And that's HCl. Flip it over. Again, I suggest you pause the program, make sure you can balance it. Make sure you can answer it. All right, number 7, we're looking at a 2,2 to balance. We're looking at 0.83 for a molarity, 0.0745 liters. We're looking for the molarity of the NaOH, 0.038 liters. I know the most about my H2SO4, so those are the moles I can get. So I'm going to multiply my molarity times my volume. Got to get my moles of H2SO4. Then I notice this is a 1 to 2 ratio. 1 to 2. So I'm going to double my moles to get me moles of NaOH. Then I'm going to set that equal to, I'm looking for molarity, and I have volume of my NaOH from what I read here. Divide both sides by 0.038. And the number we're looking at is 3.16 molar sodium hydroxide. Pause the program here. Try number 8. All right, looking at number 8, and the first thing you should notice is that it is balanced. The second thing, it says vinegar contains acetic acid, which is right there. Determine the molarity of the acetic acid. That's my question. I have a 15 milliliter sample that's going to turn into 0.015 liters. It requires 0.55 molar and requires a certain amount. Sorry, it's off the screen there. You have it on your paper. 0.0227 moles of that. What do I know the most about? I know the most about sodium hydroxide. Pause the program if you would like to get going from here. So I'm going to multiply these two things together and get 0.12 moles NaOH. Okay, so now even if I go from here to here, I go backwards, but it's still a 1 to 1. So that's exactly how many moles of vinegar I have. I'm looking for the molarity of vinegar, and I have the volume. So in order to do this, divide this by 0.015, divide this by 0.015. You are looking at 0.80 molar. All right, now we have two thinkers coming at you. My suggestion is to pause the program and see if you can't figure it out yourself. Read through every one and make sure you can try it. I mean, it doesn't help just to watch this. And then the other thing is, once I get going, if you start to think you can get it, pause it as soon as you can and finish it off by yourself. All right, let's read what the thinker says. It says, consider the following chemical reaction. I have barium chloride and copper 2 sulfate. It's going to make barium sulfate and copper 2 chloride. The stockroom has the following solutions. I have 1 molar copper sulfate, and I have 0.3 molar barium chloride. How much of each solution would be needed to produce 2.88 grams of solid VaSO4? Okay, so that's all the information I have. Let's take a look at this, and I want you to tell me which one do we have enough information to put into moles. Hopefully you said the barium sulfate, because as soon as I see grams, all I need is a periodic table to do moles is equal to, mass over formula weight. So I know that we can always find moles of VaSO4. So I'm going to start by finding moles of VaSO4. So I want you to start there. Again, pause any time that you think you know what you're doing. 2.88, and when I add 1 barium, 1 sulfur, and 4 oxygens, I get 233. Divide that up. That's how many moles of barium sulfate I need. Now the question is asking what volume of this and what volume of this are needed. Now remember, this both said they're solutions, so we can't do moles of mass over formula weight again. Pause it if you think you know what you're doing, give it a try. All right, so what we see is we have a 1-to-1 ratio here. So I need 0.012 moles of both of these materials, and both of them are solutions. So if I say, hey, I need 0.021 moles of this, that's equal to, I have my molarity and I want my volume, how much of this do I need to measure out to make exactly 0.012 moles of that? Okay, divide both sides by 1, makes it easy. Okay, and again, the number is spit out in liters, but we would probably measure it out in milliliters in class. If you think you can do the last one, pause the program and try the last one by yourself. Good. This is how many moles of barium chloride I need. I know that the molarity is 0.3. What volume do I need? And what am I doing here? Dividing this by 0.3. Dividing this by 0.3. We're looking at 40 milliliters, or 0.04 liters, of BaCl2. All right, number 10 is also a thinker. Now I want you to try to read it and see what you can do. All right, a student measures out 58 grams of baking soda. So this one says baking soda. So we're going to, 58 grams. I guess we should have said, make sure that it's balanced. I'm so sorry. And the last one was balanced as written. So making sure it's always balanced. So if I'm starting with 58 grams of baking soda, then performs the following experiment. The student achieves 100% yield in this chemical reaction. The student then takes the solid product from its reaction and dissolves it in water to make a total final volume of 95 milliliters of solution. What is the final molarity of this new solution? Well, let's see. Okay, so I know I have 58 grams of baking soda. No matter what I'm doing, I'm probably always going to put this into moles. So I'm going to take 58 and then 1 sodium, 1 hydrogen, 1 oxygen, 1 carbon, and 3 oxygens gives me 84. Now let's see. I have 0.69 moles of baking soda. It says we're going to take all of the solid products. So this is what I'm looking for. We know gases fly away, gases fly away. So I want to know how much of this I'm going to make. This is a what to what ratio? 2 to 1. 2 to 1. So I'm going to have half as many moles be produced of Na2CO3. Now, I want you to pause here if you feel like you can finish this up. I want to know if I dissolve that into 95 milliliters of water, what would be the final molarity? What would be the final concentration? Okay, what is your molarity? Is moles over volume in liters. So now, if you can figure it out from here, pause the program. All right, so I'm going to take my 0.35. Okay, I'm going to take my 0.35. And I'm going to divide it by not 95, but 0.095. And at the very, very end of the day, your molarity is going to be 3.68 molar. Okay? So again, these are practice thinkers at the back. Hopefully you will feel good with all the other ones. The thinkers are more test level. I would say the other questions are more quiz level. If you have any questions, make sure you bring them into class.